Good day everyone. Welcome to today's video lesson once again. On the board, we're having a topic titled Writing Chemical Formula. Now, what is a chemical formula? A chemical formula is a short way of writing the names of compounds using the chemical symbols of elements on the periodic table. For example, here we are asked to write the chemical formula of the following compounds. Now, we are asked to write what? The chemical formula of the following compounds. Number 1, magnesium chloride. Number 2, nitrogen hydride. Number 3, calcium chloride. Number 4, aluminium oxide. Number 5, we have hydrogen oxide. Number 6, we have sodium oxide. Number 7, we have magnesium oxide. Number 8, we have potassium chloride. Number 9, we have hydrogen chloride. Number 10, we have sodium chloride. Number 11, we have aluminium chloride. So we have to write the chemical formula of these compounds here. Now, how do we go about things like this? Now, the first thing is to identify the elements present in the compound. Without you being able to identify the elements in the compound, writing the chemical formula for the compound will be somewhat difficult. So you have to identify the elements present in the compound. Now, number 1, we have magnesium chloride. In this compound here, we have 2 elements there, which are magnesium and chlorine. So this idea was changed when it's combined with magnesium. So the INE, which is the suffix, we have chlorine. This INE, which is the suffix, changed to IDE, which is chloride. From chlorine is now chloride when you combine with magnesium. So normally it is what? Chlorine. It is chlorine. When you combine with magnesium, is now chloride. So we have 2 elements here, which are magnesium and what? And chlorine. Now, let's write out the chemical formula of magnesium chloride down. We have 2 elements present here, which are magnesium, and we have chlorine. Magnesium and chlorine. That is the first thing to do. Identify the elements present in the compound. Now, the next thing now is to look for the valency of magnesium and the valency of chlorine. Because remember, valency is defined as the combining power. Is defined as the combining power of any element. So, looking for the valency of magnesium now, we have to look for the atomic number. From the atomic number, we will now bring out the electronic configuration using the K element. So the atomic number of magnesium is what? 12. Is 12. Now, how do we write the K element configuration for magnesium now? That will be what? 2, 8, 2. Because 2 plus 8 is what? 10. 10 plus 2, you have what? 12. So the K shell has 2, the L shell has 8 and the M shell has 2. So KLM, 2 plus 8 plus 2 give us 12. Now for chlorine now, the number of chlorine is what? 17. Chlorine is number 17. Now for chlorine now, it is what? 2, 8, 7. That is for chlorine. 2 plus 8, we have 10. 10 plus 7, we have what? 17. Now, from here now, you can now get the valency of magnesium and get valency of chlorine. So now, how do we get the valency? Magnesium here, to attain the octet rule, it needs to give out these two electrons. So magnesium gives out the 2 electrons to attain the octet rule. So that will be, so magnesium you have 2 here. Magnesium you have 2 at the top here. Now chlorine on its own, chlorine needs 1 electron to attain its octet rule. So chlorine we have 1 here. Chlorine we have 1 here. You can say plus 2 and minus 1. That is the oxidation number. That is the oxidation number of magnesium. Plus 2 minus 1. So the valency is what? 2. The valency for chlorine is what? 1. So what's the next thing here? We cross it. We bring this one here and we bring this one here. So we now have, when this 1 comes here, we have 1 here. When this 2 comes here, we have Cl2. So finally we have what? MgCl2. Final answer. So this is the chemical formula for magnesium chloride. MgCl2. That is the chemical formula for magnesium chloride. Now, number 2 now. Number 2 now. This is number 1. Number 2 now, which is nitrogen hydride. Nitrogen hydride. Now, how many elements do we have here? We have what? 2 elements here. We have 2 elements, which are nitrogen and hydrogen. So we have nitrogen and hydrogen here. So when the hydrogen combine with nitrogen, we have nitrogen hydride. So what happened there? The OG, okay, let me write the name in full. We have hydrogen. So what happened here was that this OGEN, which is the suffix, when you see an element, when you combine with nitrogen, what happened? The OGEN change to what? IDE. So we have what? Nitrogen hydride. It's no more nitrogen hydrogen anymore, because it's now a compound which is called nitrogen hydride. Now, so we have 2 elements here, which are nitrogen and hydrogen. So what is the atomic number of nitrogen now? It is what? Now let's count. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. That is number 7. So we have 7 here. How about the atomic number of hydrogen? That is what? 1. This is 1. So writing the K element configuration for nitrogen, we have 2, 3. For hydrogen, we have just 1 here. We have just 1 here. So what happened? Nitrogen here. Sorry, it is 2,5. 2,5. So nitrogen here needs what? Needs 3. It needs 3 to attain the octet rule. I repeat, nitrogen needs 3 to attain its octet rule. So we have 3 here. Now hydrogen here, on the other hand, needs 1 to attain the what? The duet rule or the duplet rule. So hydrogen needs what? 1 to be stable with the duet rule. So what happened here? You cross it again. So the 1 comes here, the 3 comes here. So we have 1 coming here. We have 3 coming here. Finally, we have what? NH3. So this is nitrogen hydride. The common name is ammonia. That is the common name. NH3, the common name is what? Ammonia. That's for number 2. Number 3 now. Number 3, we asked to write the chemical formula of calcium chloride. Now, how many elements do we have here? We have 2 elements, which are calcium and chlorine. Like I said here before, the Ne here changed to what? De when it combined with calcium. So we have 2 elements here, which are calcium and chlorine. So we have calcium and chlorine. Calcium and chlorine. So now, what is the atomic number of calcium? That is what? Number 20. What is the atomic number of fluorine? That is what? 17. 17. Now, with the KLMN configuration for calcium, we have what? 2, 8, 8, 2. That is for calcium. For chlorine, we have 2, 8, 7. So 2 plus 8, we have 10. 10 plus 8, 18. 18 plus 2, we have 20. For chlorine, 2 plus 8, we have 18. 2 plus 8, we have 10 rather. 2 plus 8, we have 10. 10 plus 7, we have what? 17. Now, with that being said, we have what? Calcium here, and we have chlorine here. Now, this calcium here needs to give out these 2 to attain the octet rule. So so we have it give out 2, so we have 2 here. Now, chlorine here needs what? Needs 1. Chlorine needs what? Needs 1 to be stable with the octet rule, so we have 1 here. Now, what's the next thing here? We bring the 1 here, we bring the 2 here. So we have calcium, the 1 comes here, so we have 1 here. So we have Cl, the 2 comes here, so we have 2 here. Lastly, we have what? Calcium chloride. So this is the chemical formula for calcium chloride. Now, if you notice, something is taking place here. If you notice, when calcium loses these 2, we now have calcium to now be what? 288. This calcium here is now stable. Now, when chlorine got 1 to this here, to this 7, we have 2, 8 and what? 8. So they are now both stable. Now, for number 4 now, for number 4, we have aluminium oxide. So we are asked to write the chemical formula for aluminium oxide. The same thing also. How many elements do we have here? We have what? 2 elements here also. Aluminium and oxygen. So we have the suffix of oxygen to be what? So we have oxygen now changing to what? Oxide when it's combined with another element. So we have the suffix here changing to this. So from oxygen you have what? Oxide when it's combined with another element. So we have 2 elements here which are aluminium and oxygen. So we have aluminium and oxygen. So we have aluminium and oxygen. Now, what is the atomic number of aluminium? It is what? Number 13. Number 13. So we have 13 here. And what is the atomic number of oxygen? That is what? Is number what? Number 8. Number 8. Now, aluminium now, the key element configuration, the key element, we have 2, 8, 3. 2 plus 8, we have 10. 10 plus 3, we have 13. Now, for oxygen now, we have 2, 6. 2 plus 6, we have what? 8. Now, this aluminium here now needs to give out these 3 to become stable. Aluminium needs to do what? Give out 3 to become stable. So we have aluminium having 3 here, and we have oxygen here. Oxygen on the other hand needs to gain 2 to become stable. So we have 2 here for oxygen. So what's the next thing here? Bring the 3 here and bring the 2 here. So we have the 2 coming here, we have the 3 coming here. So now I have what? Al2, the 2 coming here, and we have what? O3. We have Al2O3. So this is aluminium oxide. If you notice here, what happened here? When this 3 goes to oxygen, we now have 2, 8 for aluminium, which is now stable. For oxygen, we have 2, 8 also. If we gain 2, we gain 2, now have 2, 8. So if this one loses the 3, now have 2, 8. So it is now stable. So this is the chemical formula for aluminium oxide. So now number 5 now. Number 5. Number 5 now. We have hydrogen oxide. In this compound also, we are having 2 elements likewise. We are having hydrogen and then oxygen. So we are having hydrogen and then oxygen. The atomic number of hydrogen is what? 1. The atomic number of oxygen is what? 8. So the K element configuration for hydrogen is what? 1. And the K element configuration for oxygen is what? 2, 6. So hydrogen needs 1 to attain the duet rule. So we have 1 here. And oxygen on the other hand, this oxygen here needs 2 to attain the octet rule. So we have 2 here. It needs 2, so we have 2 here. So what's the next thing? We bring the 2 here and bring the 1 here. So we have H2O1. The 2 coming here, we have 2. 1 coming here, we have what? 1. So we have what? H2O as hydrogen oxide. And the common name for this is what? Water. That is the common name for H2O. Hydrogen oxide is what? Water. You can name this one like this. You can name it like this. You can name it dihydrogen oxide. Dihydrogen oxide, because we have 2 hydrogen here and we have 1 oxygen here. So you can name this one dihydrogen oxide, or you can name it dihydrogen monoxide. Mono is 1, di is 2, tri 3, 4 is what? Tetra, over 5. 5 is what? Pent. So we don't need to put that monoxide in most cases when it comes to just 1. So better still just call it what? Hydrogen, or let me say dihydrogen oxide, or better still hydrogen oxide. So this is for number 5. So we have 2 here. If it gains 1, we have 2 here, which is now stable. If it gains 2 here, we have 2,8, which is now stable. That is for number 5. For number 6 now, number 6, we have sodium oxide. Sodium oxide. Also, we have 2 elements present here, which are sodium and oxygen. Sodium and oxygen. Now, what is the atomic number of sodium? The atomic number of sodium is what? 11. That is 11. The atomic number of oxygen is what? 8. Now, with the KLMN, we have 2,8, 1. For this one, which is oxygen, we have 2,6. To be stable, what happened? This sodium here loses 1. So you have the sodium here having 1. To be stable, oxygen needs to gain 2. So you have 2 up here. They are up, not down here. They are up. So bring the 2 down here, bring the 1 down here. So now I have Na, these 2 coming here, we have 2, and we have the 1 coming here, so we have O1. Finally, we have Na2O. So this is sodium oxide. This is sodium oxide. So that is for number 6, sodium oxide. For number 7 now, number 7. Now for number 7, we have magnesium oxide. Magnesium oxide. How many elements do you have here? We have 2 elements, which are magnesium and oxygen. The atomic number of magnesium is what? Is number 12. For oxygen, we have what? 8. For magnesium, you have 2,8, 2. You have 2,6. To be stable, magnesium has to give out these 2 to attain the octet. Magnesium is stable with the duet rule already. So, but it can still be stable with the octet rule by giving out the 2 here. So we have magnesium giving out 2. When it gives out 2, so we have 2 here. What about oxygen? Oxygen here needs 2 to attain the octet rule. So when this oxygen gains 2, we have 2 here. So bringing this 2 here and bringing this 2 here. So we have Mg, these 2 coming here, 2, and these 2 coming to oxygen here, we have O2. Now 2 is common to both. 2 is common to both. So we have 2 here, 2 here. So we have MgO, Mg. So this is the chemical formula for magnesium oxide. Magnesium oxide. Now, number 8 we are asked to write the chemical formula for potassium chloride. How many elements do we have here? Potassium and what? Chlorine. So we have potassium and chlorine as the elements present right here. Now, the atomic number of potassium is what? So we have what? It is what? Number 19. For chlorine is what? Number 17. If you count, we have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and what? Calcium. So we have potassium here at number 19, calcium number 20. Now for chlorine is what? 17. So the K element for potassium is what? 2,8,1. That is for potassium. For chlorine we have 2,8,7. That is for chlorine. We have 2,8,7. For potassium we have 2,8,1. So potassium here needs to give out 1. Potassium is what? 2,8,1. Chlorine is what? 2,8,7. Now potassium needs to give out 1 to attain the octet rule. So we have potassium having 1 here. We have chlorine needing, so chlorine needs 1 to attain the octet rule also. So we have chlorine having 1 here. So when we cross it, we bring the 1 here and bring this 1 here. So we have potassium to be having 1 and chlorine also having 1. So lastly, we have KCl. Now, if we check for potassium here, when we give out 1, we now have, for potassium, we now have 2,8,8. Now stable. It is now stable. When chlorine gets 1, we have 2,8,8. So they are now both stable now. So that is for number 8, potassium chloride. Number 9. For number 9, we have hydrogen chloride. So how many elements do we have here? We have hydrogen and chlorine. The atomic number of hydrogen is what? 1. The atomic number of chlorine is what? 17. So we have 1 for the K element, For chlorine, we have 2,8, 7. So this hydrogen here needs 1 to be stable to attain the duet rule to be stable, because atoms are stable with 2 rules. Atoms are stable with 2 rules. The duet rule, you can call it the duplet, and the octet rule. For this one here, if it's ending with 2, it is stable. If it's ending with 8, it is stable. Now, in the case of magnesium is number 12, which is what? 2,8, 2. As it is now, magnesium is stable with the duet rule, but it can still react with other elements by giving out these 2 to attain the octet rule, to be stable by the octet rule. So if it gives out these 2 to other elements, mostly in group 6, it can still be stable with the octet rule here. Now, hydrogen here now needs 1 to be stable with the duet rule, so we have 1 here. And chlorine needs 1 to be stable, so we have what? 1 here. So chlorine needs 1 to be stable, so the 1 comes here and the 1 also comes here, so we now have what? H1Cl1. So finally we have what? HCl. This is for hydrogen chloride. So I'll give you these 2 as your assignments, so you can put it down in the comment section. Please do well to hit the subscribe button, like, comment and share, so that this can be of help to other students as well. Now, I'm still going to have a part 2 for this chemical formula when it comes to writing compounds like hydrogen tetraoxosulfate 6, calcium carbonate, sodium carbonate, and things like that. So I'm still going to have part 2 on this writing chemical formula. So till next time, may the grace of our Lord Jesus Christ be with every one of us. Amen. Thank you very much.